Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, we're gonna take a look at list zipping node in Sverchok. It's so this is more like a basic kind of video live noding. So if we open Blender and then we are inside this Sverchok node tree, we can have a look for list zip. Okay, the node looks like this, and so it's expecting data. And list zip is one of those special nodes. If we provide like a like a bunch of data, it will give you options to give it more data. So that's kind of obvious. And the result, if we check using the stethoscope, is basically it looks like a list, right? What's so special about list zipping? So one of the example we can do is if we use like a range of float, for example, range of float, and let's give it like a maybe we want like 5. So the range of float will give us like a list of numbers. If we give it like, okay, start from 0, stop at 10, give me 5 numbers based on that start and stop. So we have this number. If we, okay, let's see, this is like 0 to 5, for example. 0, 0, 1, 2, 1, 2, 3, 4, 5, maybe 0 to 4. Actually, range is actually easier to read. So start at 0, stop at 5, step 1. So 0, 1, 2, 3, 4. Okay, this is the first one. It's we have how many? 1, 2, 3, 4, 5. Okay, 5 numbers. If we plug it there and then we plug it here, if we make this one start from 6 and finish at 10, which is let's check the number. 6, 7, 8, 9. Maybe start at 5. So we have 5, 6, 7, 8, 9. So we have these two lists, 0, 1, 2, 3, 4, and then 5, 6, 7. You look at the zip, we get 0. We have list of lists. That's the inside is like a 0, 5, 1, 6, 2, 7, 3, 8, 4, and 9. It's like it's just like a zipper. So a zipper looks like this, and you zip it together. So you have this value, and then you can actually have more. I'll save it real quick first. It's a list zipping. We can unwrap it, and we have this list that's slightly different. We can use level 1 or level 2. Actually level 1 is usually sufficient. We can also have another one, like maybe this one from 10 to 15. Look at the value. Okay, we can plug it in, and now we have lists like a XYZ kind of pair. In this example, I will actually use the 4 value. So 4 value pair. So zip is usually when someone say I want a pair of numbers, like I have a list A and then I have list B, and I want to pair them together. So I have like A1, B1, and then A2, B2, and so on. So we can actually study this using Sverchok nodes and Python scripting as well. I'm gonna kind of want to touch Python slowly, starting from Python function. So let's have a look at this page here. This is a Python code built-in functions. We have the newer versions, I think 3.6. What's the one Blender is using? Let me check. I think 3.5. So 3.5. Okay. And let's grab our zip. This is a list of functions in Python, all functions, and this one in particular is the one I'm interested in. So zip, zip is make an iterator that aggregates elements from each of the iterable iterator of tuples, where the number of tuple contains the ith element from each argument, blah blah blah. So let's look at the example here. Okay, just copy paste the example. So we're gonna be touching Python, but it's not like in linear kind of learning. It's not from start to the end. I'm just jumping around because maybe that's how you can learn Python, how you can learn programming and noding, coding and noding. So we look at this example, and then okay, let's create first. Okay, list of x. X has 1, 2, 3 number. Y has 4, 5, 6. And zip equal zip x and y. So zip is the variable name. If we test it, what is zip? Zip is a zip object, blah blah blah. If we print out, if we use list functions to look at the inside of the list, we have 1, 4, 2, 5, 3, 6. It's exactly 1, 4, 2, 5, 3, 6. We can do the same in Sverchok. So if we have a bunch of numbers, so create list. In Sverchok, you might actually need to use list join, or you can use the formula. Let's try 1, 2, 3 here, 4, 5, 6. Plug that in, plug that in. What do we get? We have 1, 4, 2, 5, 3, 6. Exactly the result we wanted. We can also do it like this. If we have extra number like 7, 8, 9, and then we have A for alpha, and then it's 1, 1, 1. We can zip all these 3, 4 variable. List zip. So we have a pair of 4 numbers, and we have 3 of them because originally we have like 3 numbers per list. Okay, that's the essence of zip basically, and we can use it for color in Blender. I'm gonna show you real quick. I'm using Sverchok. So we have this cube, and this cube has a material, and we can turn on object color. So with object color on and the diffuse is kind of white, we can colorize this guy. Okay, that's a good thing. And now I'll create a bunch of this guy. It's like four of them for now, and I'm gonna load it inside Sverchok. Objects in. Now I'm gonna group this guy first of all. Control G, so they are grouped, and the name of the group is group. We can get it using this new objects in node. Select the group, get selection. Now we have 4 cubes in here, and there is this thing in Sverchok, object ID and set. This is kind of like a nodes that unknown unless you're shown, but this is really useful. Like so we have a bunch of objects being sourced. We can plug in the object there, and then here we can change any kind of attribute that we want. In this case, it's color. So object color, and then it requires a value. Let's try something here. 1, 0, 0, and 1. That's to represent RGBA. R value of 1 and then 0, 0, and then the alpha is 1. So let's plug that in. And it seems to complain. Maybe we didn't provide the correct value. Maybe doesn't seem to work. Maybe a single object will work. So get selection. Actually turn off the group. I think, okay, I have to turn off Firefox. I think it's slowing down my computer. Let's wait. Let's create another cube and then assign a material, and let's get our cube, get selection, and then we have the object goes in there, and then we want to change the color. Still doesn't work. Why is this? Maybe I have to give it a value like this. 1, 0, 0, 0, 1. Let's look at the error message. Sequence expected at dimension 1. Not float. Wonder if you can just change it like this. No, maybe that's not how we do it. We will see in a second. If we use zip, it will work. I have to turn off Firefox first. Okay, let's make zip value so that this thing can work. So apparently we need like a pair of 4 value, right? Let's use a random number. And what's the size? Let's make it 1 for now. 1 value between 0 and 1. It's gonna be, let's check the value first. So it's 0.54881. Okay, that's 1 value, and then we can have another and another and another to represent the RGB and the alpha. So 4 pair of number. So I'm gonna plug this in. It's RGB and then A, and this is the result we get. Maybe for the alpha we just make it 1, so it's like this 3 value and then 1, and we can plug this into object ID set, and seems to work this time because of this the value. It's I don't know why it didn't work with the formula. It should work. Now let's see. Let me try again actually. Formula. So the value looks like 1, 2. Okay. Sometimes Sverchok can be very you need to be precise with the number. So 0.2, 0.3, and 1, 1, 2, 3. Yeah, it didn't work with that. So maybe you need to kind of modify this guy. In the stethoscope, if we check the value, it's kind of like unwrapping it one time. That's why. Need a list join probably. Need to be wrapped. one more time. So yeah, you need to kind of 1, 2, 3, 4, and then let me try making this red. Oh yes, okay, that seems to work if you use the list join. If you, yeah, that's not work, that's work. So wrap is important in Sverchok, but if you use Python and you work with Sverchok, you will see that this idea of wrapping list inside list, like a compound list, is quite common in Sverchok and also Python. So anyway, we can put our value that way, and then so we can delete this cube. Let's grab our group once again. Start again. Get our group. Get selections, and now all our cube is red color. Cool. How about this guy? How about this guy? Let me tidy up a little bit. So let's put this guy up there, and let's cut this. We don't need that. So this is just sourcing all our 4 cubes, and this object ID set can set any kind of attributes name. You specify the attribute name here, and then you provide the value here. It's as simple as that. So we just plug in the value there, and then we get a grayscale because our RGB is the same number, the same random number. We should randomize the seed. So now we have like a random color, but it's still the same for all of them. Why is that? Because we didn't provide like a list of value. We only give like a single value here. You see? So we need to have how many objects? 4, but we don't want to having to specify the number of objects each time. We want it that if our object kind of grow or kind of reduce, it will update automatically. So plug in the object data there, and then check the output of this list length. It didn't give anything. It should be level 0. Now we have the number. It says 4. Okay, 4 should go into the size of this guy. 1, 2, and 3, and also the alpha. So if I tidy up, this guy should be like this. This should get the total number, and this should give the RGB value. I can make it more clear here. Give it a color R, G, B, and A, alpha. So RGBA being zip, using list zip that we have learned, and it goes there. Let me quickly do something. Sverchok. Yeah, this is easier to read. So okay, this one applying the color into our objects. Now we can see our object has a random number, random color number. So RGBA. Sverchok currently doesn't have a HSV yet, the HSV, but you can actually make that yourself using Python and script node. So it will be handy, of course, to have this HSV. For now, it's just a RGB. It's okay, and the alpha. You can see here in the list output we have RGB, random RGB color, and then alpha, RGB, and alpha. All those the usual thing. So with this setup, we can simply have more objects, and then updating Sverchok, like using this guy, will update the color. Have more. Get selections, it will update, and then every time we make changes into the seed of RGB, it will give us a result right away. So this is one usage of zip. I guess it should be pretty clear now. So zip, again, is super useful function in Python and in Sverchok. You provide like a bunch of lists, so list A, list B, and list C. Make sure the numbers are the same, the total number of elements of maybe A1, A2, B1, B2, and C1, C2, and then you can have as many, but it will, as long as the total number is the same, and it will zip it into a single kind of a pair. So this is very useful. You can, of course, write your like a script node that does all these if you want. That's gonna be homework if you want. Anyhow, this is how you do it using kind of nodes, using a node. I like it using nodes because it's really simple. And you of course you can type it. It's not, it's like optional, but eventually after you're doing a lot of noding, you want to learn about coding, because coding can be a little bit faster. Maybe all these can be simplified into few lines of code, maybe. It's just like a different way of working. Yeah, I guess that's pretty much it. What else we can do with this, with all these objects? No, I guess I just leave it there for now. Yeah, hopefully this is useful for you. This is, so to summarize, this is me talking about Python zip functions and how you do it using code, and how you use it. You use node, and kind of makes sense if you put it in a little exercise setup like this. Yeah, if you have any comments, question, you can leave it down below. Thank you. See you in the next video.